Hi there, dear friends. We've got this rugged Land Cruiser from 1993 with a stubborn ignition problem. We have no spark in the coil lead, that is the central wire that goes to the distributor. What are we going to do this time? We're going to check the voltages arriving at the coil, this here now. We're going to check the voltages arriving at the distributor. And with that, we will know exactly what is happening with this van, and we can start diagnosing the problem together without delay. Yes, some of the voltages I mentioned to you from the distributor's connector or from the coil are not present, which is why it isn't producing a spark. For this job, we will need a multimeter and two flat blade screwdrivers, one small and one medium now. Some long nose pliers, a wire for making simple jumpers, crocodile clips, and a compact current tester. That is all we shall need to begin our diagnostic work on this 1993 Land Cruiser equipped with a 4.5-liter engine. Remember that it comes from the 80 series. There you can clearly see the year of your car. Here on the front of the bonnet is the decal, for quick reference here. Here is 1993. The 4.5-liter engine here is the 1FZ-FE engine. Okay, what exactly is this that we have here in front of us? The very first thing we're going to do is carefully disconnect our distributor's central cables, which is the one visible right here. And we're going to check whether we have a spark. This is how we do it. We will bring it as close as we can, gradually and carefully, to ensure the distance is minimized. Any metal part, and the part that has the most insulation on it, we will touch from that point and bring it even closer. Go on, please. Well, no, we don't have any spark at all. So yes, it is in fact an ignition problem, and we still don't have a spark here. The other test we're going to perform is to disconnect the wire from the ignition coil. Here, there is what looks like a tiny clamp. We're going to remove it from the coil and check to see whether there is a spark there. An easy, straightforward way to verify the coil is to carry out this check. And if you are seeing a spark coming from the coil, the proper procedure is to attach a crocodile clip to earth, connect it to a screwdriver, and to position it adjacent to the coil itself there now. Very well indeed. No, we do not have a spark either. If we had a spark here and did not have it on the other end of the cable, the problem would be the cable. The cable would be open, but in this case that isn't so. The spark does not come from the coil, nor from the cable either. So we're going to the next test. Very well indeed. The next test we're going to perform is to check the voltages at the coil and at the coil itself, or at the coil. For reference, this will help. To that end, we're going to use a normal current tester. Yes, connected to the negative terminal. When we detect voltage, it will illuminate exactly as it is lighting now. Right, we move to the coil. There it is at last. All set now. Now we have two cables, one black conductor with a green wire and another black conductor with a white wire on both ends. There must be voltage when the switch is open. Please open the switch. There is voltage present on one wire right here. Let's also thoroughly check the other wire. We have voltage on both wires, which means the voltage is fine and the coil is fine. What would happen if the coil did not work at all? The voltage from this cable would not pass to the other cable at all. That other wire, in other words, we'd have voltage only on one wire. When that happens, the coil does not work. It's open now. In this case, it's working well indeed. Okay then, now we'll check voltages that should reach the distributor beforehand. We've connected the multimeter to the battery's negative terminal with an alligator clip and the positive terminal here. We're going to disconnect the distributor's 4-wire plug and we'll verify the setup. And we'll clearly check the measurements for accuracy right now. Across these 4 conductors, there should be at least 0.7 volts across them at all times. As you can see at the moment, it is showing 0.023. We're going to touch each of them, 0.011, 0.011, 0.011. And 0.011, none of them have the 0.7 volts. So the problem is here. The voltage isn't actually reaching the distributor's connector. Okay, let's proceed with the diagnosis. We'll check why our connector, this distributor's connector, doesn't have the 0.7 volts that we were hoping it would have. First things first, the very first thing that we're going to do is to check and inspect our fuses. The fuses are located in this particular area here, directly beneath this door. Yes, we will make sure that the switch is open at present, at the moment it is open. We are going to use our tester once again. We will carefully place it on a part that has metal. Yes. There it is indeed. And here at the backside, this is the section where you can readily see precisely what each fuse is for. And here we're going to search for the fuse that says ignition or ignition, which is the third one. We start at the very top and carefully work our way down until we spot it. There it is indeed. So we're talking about what this thing here actually is, right? That one has to have voltage, as it should be, for sure. There you go. It must also have voltage from the other side. It has that as well. So this isn't the problem. Everything's fine. We'll put our lid back on again as we proceed now. Yes, this is not the problem. Very well. Let's continue with our diagnosis. Now we know there is no voltage here, and we'll check the fuse inside the ignition. Now we'll check the relay, just to be sure. Where's this relay then, right? This relay sits beside the starter, up front where the battery is. There's a box that houses the relay. This is where the relay is. What is this thing? This particular one here is going to zoom in so that they may see it clearly. EFI main says so. Right now, we are going to carefully remove the box as planned. Yes, and we're going to extract this relay, if you please, right away. Blimey, it feels hot, doesn't it, at all? That isn't a good sign at all. Yes, indeed, the same goes for me. We will use our trusty voltage tester on this pin here, please, as we discussed earlier. The one in the corner should always show voltage at all times. Yes, we indeed have voltage, and this voltage will pass over to this side whenever the relay closes on any one of these two devices, which is essential for continuity testing indeed there. We must have voltage when the switch is opened. Please open the switch. Very well. Go ahead and shut it now. All of that is currently working fine. At this moment, we are going to inspect things because this relay, together with the part that is getting hot, is no longer a good indicator. Therefore, there could be an internal poor contact, and that is why it is gradually heating up indeed. What we're going to do at this very moment is to place a bridge from this pin to that other pin. I will point them out to you very clearly using the tester for this pin. For this pin, we're going to construct a bridge. That is, we will do exactly what the relay normally does under ordinary operation. I'm going to close these two circuits or connect these two circuits. Okay, what we're going to do to test whether our relay has a bad contact is that we're going to find a way to reliably close the contact the relay normally closes when it operates. Remember that we have a voltage here, and this voltage is fed across here. So what we're going to do here is simply bridge it. Usually I use a wire with tinned ends to make that bridge, and we're going to do it right now. Very good indeed. We've already made the bridge, as you can clearly see there. Both cables are already connected and securely in place, and we're about to press the start button to check whether there's a spark in the coil lead. Could you please do that, please, right now? Again. Very well indeed, there's the spark. The problem lies with the relay. That's what's causing us, that is. That is why it got hot. It is, in fact, a relay. Well, the original unit is a very dense one. Here come the data, the figures, and specifications. It is 12 volts, 22 amps at the moment. Let's see if we can go and obtain it so that we can install it properly. And with that spark, it should at last start the car. Very well. Then we are back here once again to carefully inspect the relay. We went to AutoZone, and after a search, we found this relay, which appears to be exactly the same in every respect. It bears the number 19829 if it happens to be from the Duralast brand, and this one just also seems to be completely identical. Here we have both of them, right in front of us. The one on the right-hand side is the old unit, and this one here is the Duralast. As you can see, it is exactly the same. In fact, there is nothing different here. Now then, we're going to start by installing it. Yes, it has a notch, as you can see up there, and down here it also has one. It's the one that is there, so we will install it with that notch facing over there. There we go, and it has to click into place. There's another one already. Okay then, and now we are going to test it. We will test it now. The coil cable is in place. Let's see if it starts up now. Please go ahead. Well done. Well, that was all I had to hand at the time. Then as we saw, we carefully checked that there was no voltage at the connector there. We checked the fuse thoroughly, of course. We checked the voltages on the coil here. They were all fine. We checked the cable as well. It was all fine, obviously. And when we came to check the relay, we found that it was hot now. We ran the test, we briefly jump-started it, and we had a bright spark. So with that, the car started right away. Remember, for a car to start, it needs 3 essential things indeed: compression, fuel injection, and spark at the plugs. If any one of these 3 essential elements is missing, the car simply won't start at all. Then it was relatively easy here. Don't forget, first you must check that all voltages at all of your distributor and coil connectors are present. Remember that here they are 0.7 volts in each of them, and here they are 12 volts. This is tested with a multimeter. Here you test with the current tester. All right, folks. Well, that's all. We proceed to seal up our relay and fuse box, yes, and the case is resolved. Don't forget to subscribe and please click the bell so you know precisely when we upload these videos. This truck is extremely epic because it is used very heavily for adventures, expeditions, and other kinds of outings and jobs. The client asked us to restore it to its former glory. That is, all those faults, like this one, that were intermittent, we will remove as we go. So we will make it more reliable, and we will start doing different kinds of work on it. So you can put it wherever you want because it is used a lot for trips and routes and all that. So we're going to continue with videos about this kind of car in an upcoming video. We'll clearly show how the distributor's internal components are tested and how it is tested, the ignition module that's here right now, and the coil separately, how they're tested and how we can verify the components separately. Whether we have the spark or not, we have the spark. Stay tuned for this. We're also going to upload those videos too. See you later.